All right, folks. So we are going to now talk about the general form of a linear relation. So we just learned probably the most used and kind of arguably one of the more often forms you'd see is the slope-intercept form. Remember that includes the slope and the y-intercept. But there are multiple forms to represent a linear relation. And this is a new one. It's called the general form. So what can I do? Well, you must be able to represent the equation of a graph in general form. So something to note is this a number, it has to be a positive integer when you do this. Now, what is an integer? An integer is just like 1, 2, 3, 4, 5, 6, so on and so forth. No decimals or anything like that. And it has to be a positive number. So that's the most important thing right now is a has to be positive and it has to be a whole number. A, B, and C must all be integers, okay? So like this can be a negative number and this can be negative, but it also has to be 1, 2, 3. Okay, so like A has to be the numbers 1, 2, 3, 4, 5, so on and so forth. And then B and C, they are allowed to be negative numbers, but they also have to be an integer. Okay, we have to understand what it means when a is 0. Okay, so what happens when a is 0? Well, that actually means that you're dealing with a horizontal line. And understand when a line is where b a vertical, where b is 0. Okay, so just as a little recall here, what are integers? So we're going to use the below line as a number line. Integers, again, are just the numbers that are whole. Okay, so on and so forth. Now, for our a value can be 1 or any integer bigger than that, and then b and c can be any integer that's either negative or positive. Okay, now with the general form, our general form is always represented such as where a is next to x, b is next to y, and then c is here. This c value is known as a constant. Okay, now, and again, a, b, and c are all integers, and a has to be a positive number. Okay, now let's just recall our x-intercept, the x-coordinate of the point where a line or curve crosses through the x-axis. So the value of x is where y is 0. Okay, so remember, x-intercepts is when y equals 0, and y-intercepts is when x equals 0. So an x-intercept would be your x-coordinate, and then the corresponding y would be 0, and this would be 0, and the corresponding y-coordinate would be your y-intercept. So let's first of all figure out how do we convert slope-intercept forms to general forms. So recognize right now this is your slope-intercept form. And this equation is asking us convert the equation to general form and then sketch the graph of the given equation. Well, first of all, sketching the graph of this thing is actually easier to do using the slope-intercept form, right? So we have our slope-intercept, our y-intercept at -2. So there's our point there. And then our slope equals +3/4. So our rise is +3. Our run is +4. So we just need 2 points to do this. Let's graph a few things. So here's 1, 2, and 3. And then let's maybe go up to 4 here. So our rise is +3, so we're going up 3. So 1, 2, 3. And then we're going to do a run of 4, so 4 to the right. 1, 2, 3, 4. So our point ends up being right here. And there's our other point. And now remember, the special part about linear lines is they're a perfectly straight line. So you technically only need 2 points to solve. So that was all a bit of a review on how to use slope-intercept form. Now, how can we represent this slope-intercept form using our general form? So remember, a general form is where everything equals 0. So essentially, you're just going to move everything to one side. So right now I have y equals 3 over 4 x minus 2. And what I'm going to do is I'm going to subtract y from both sides. And now I will get 0 equals 3 over 4 minus y minus 2. So, oh, and there should be an x here. So there's x. Let's maybe clean this up a little bit just for our notes. So minus y minus 2. Now the problem here is our a value, which is the value next to x, as we can see up here, our a value, which is next to x, is not a whole number. It is positive, but it's not a whole number. Now, how do I deal with that? Once you get it into this form, in order to get rid of your denominators, you want to multiply by your lowest common denominator. And in this case, my lowest common denominator is simply 4, because 4 is in the denominator. So what I'm going to do is I'm going to multiply every single thing by 4. So not just am I going to multiply this by 4, I'm going to multiply this by 4 and also this by 4. So what that is going to turn into is I will get 0 equals, now 4 times 3 over 4. Hopefully we know how to multiply fractions with whole numbers. So 4 times 3 over 4. The 4 just multiplies by the top number, because remember, when you're multiplying by fractions, you multiply the top number by the top number and the bottom number by the bottom number. You can imagine a 1 being on the bottom of this fraction, so 1 times 4 is simply 4. So here you get 4 times 3 dividing 4, and hopefully you can see our 4 cancels out, and you're simply left with 3. Okay, so that's why you multiply by the lowest common denominator. It gets rid of your denominator. So what we'll end up getting is 3x. 4 times negative 1 is negative 4y. 4 times negative 2 is minus 8. So in this case, a equals 3, b equals negative 4, and c equals negative 8. And we can see every number is an integer, and that a value is a positive number. Okay. So let's move on to our next example here. And I'll just quickly block this off. There we go. Okay, so again, let's first graph this thing, our little rough sketch. And this also acts as a good little review on how to do these things. So remember, we want our increments to be going up by the same amount. One, 2, 3, negative 1, negative 2, negative 3. Now remember, this is in slope-intercept form, so this is my y-intercept, positive 1.5. So there's my first point. And now my slope equals negative 2. And remember, we can imagine a 1 on the bottom, so this is negative 2 over 1. So this is my rise, this is my run. So my rise is 2 units down, and my run is 1 unit right. So we can figure out where our next point would be, starting at our y-intercept. And we're going to go 2 units down, so 1, 2, and then we're going to go 1 to the right, so 1. So our first point is found right here. Oh, just hang on, that was actually not quite right, because 1 unit down, here we're at 1.5, so 1 unit down would be half, so to 0.5. And then another unit down would be right here. So that's 2 units down. And now we're going to go 1 to the right, right? 1 unit to the right. So we'll go over 1 unit right, so our point will be found right here. Okay, and remember, you technically only need 2 points, but you could do it one more time if you really wanted to. So 2 units down, 1, 2, so negative 2.5, and then 1 unit to the right, so to positive 2. And now you could connect all these points, and you're going to notice that it creates a perfectly straight line, because this is a linear relation. So there is the equation, the graph of the equation, negative 2x plus 1.5. Now, let's put this into general form. So remember, general form is ax plus by plus c equals 0. So this one's quite simple again. We're simply just going to take our y value and subtract it from both sides. So I'm going to do minus y. So you'll end up getting 0 equals negative 2x minus y plus 1.5. Now here we have a few problems. First of all, my a value is not negative, or is negative, must be a positive. And here, this is not an integer. So how do we deal with this? Well, first of all, let's represent our decimals as fractions. So this will be negative 2x minus y plus 3 over 2, right? 3 over 2 equals 1.5. So from here, now I have a fraction, and my front number a is not positive. So how are we going to deal with this? Well, first of all, you're going to multiply everything by the lowest common denominator. The only denominator here is 2, so I'm going to multiply everything by 2 to get rid of that denominator. I also need to make this a positive number. How do I make that a positive number? I'm going to multiply by negative 1 to change this sign here. Okay, so in total, what I'm going to do is I'm going to take everything here and multiply it by 2 and times negative 1 as well. So you can simply represent this as negative 2. So negative 2x minus y plus 3 over 2. I'm going to multiply by negative 2. And remember, we're multiplying everything by negative 2. So that will become negative 2 times negative 2 is positive 4. So this will become positive 4x. Negative 2 times negative y gives me positive 2y. Negative 2 times 3 over 2, well, we get our 2's to cancel out, and we still get that negative 1 times 3, which is negative 3. So this will become negative 3. And there is our answer in general form. So this is our a value, so a equals 4, b equals positive 2, and c equals negative 3. So there is us converting our slope-intercept forms into general form. Okay. So let's maybe see another example here, a few more examples, and then we'll move on. So recall, a linear line only needs 2 points to graph the equation. So we've mentioned that quite a few times, so hopefully it's stinking in your brain. And if it doesn't really make sense, please come in and ask some questions. If we can find 2 easy points, such as the x-intercept, so remember the x-intercept is pretty easy because that's simply when y equals 0. And the y-intercept, which is simply when x equals 0, we can simply connect the 2 points to graph. So sketch the graph using intercepts. Okay, well, I'm going to find my x-intercept here. And remember, this isn't in slope-intercept form, so if it was in this form, we would graph it using a different method. But now we're going to graph it using another method. Okay, we're going to use it just by finding some simple points. So my x-intercept is when y equals 0. So I'm going to plug in 0 for y and solve for x. So this would be 4x plus 5 times 0 minus 20 equals 0. And now I'm solving for x. So 5 times 0 is 0, so this becomes 4x plus 0 minus 20. 0 minus 20 is negative 20, so 4x minus 20 equals 0. And now we'll add 20 to both sides. And then finally divide by 4. So we have a point now on our graph at x equals 5. So remember, this is the x-intercept, so when x is 5, y is 0. So that'll be a really useful point to plot. Now let's find another easy point, aka our y-intercept. So when x is 0. So now I'm simply going to plug in x with 0 and solve for y. So this will be 4 times 0 plus 5y minus 20 equals 0. 4 times 0 is simply 0, so that just cancels out. And we're left with 5y minus 20 equals 0. And now you're simply solving for y. So add 20 to both sides, and then we'll get 5y equals 20, and we'll divide by 5. So y equals 4. So remember, y equals 4 when our x value was 0. So this is 0 and 4. So here's our y-intercept, and here's our x-intercept. And now you have 2 points on a linear graph, so you can easily solve. So I'm just going to make an x-axis here, or sorry, a y-axis here. And obviously try and put that right on top of the line here. And then I'll make an x-axis here. There we go. And let's make it every tick is 1 to make our lives a little easy. So this will be 2, this will be 4, this will be 6, 2, 4, 6, negative 2, negative 4, negative 6, negative 2, negative 4, negative 6. And now we can plot. So 0 and 4, where is 0 and 4? Well, when x is 0, y is 4. And remember, this is simply just a x-intercept. And then when x is 5, y is 0. So that's found right there. And now we can graph these, because since this is a linear line, you can simply just connect these points. So here we'll get something that looks, we'll have to adjust how that looks a little bit. So I will move this over, and then this, and of course you would want to grab a ruler. That's the best way to do this. So it looks roughly like that. And remember, this goes on forever, so we'll put little arrows stating that this is continuing on forever. Okay. Another way you could have done this is convert to y equals mx plus b, and then solve for that. And you would get the exact same answer. But it's also important to note, how do you just graph given a general form? When you're given general form, you have to solve for some points that exist on the graph. So in this case, use really easy points like x-intercepts and y-intercepts. Okay, so hopefully that made sense. Let's now just quickly talk about vertical and horizontal lines using the general form. So remember, sometimes you have horizontal lines, and remember, we think about horizontal lines as points that go across like this. And remember, that is where it's like y equals -6 or y equals 5. So that was talked about way at the beginning of this section in another video. We talk about horizontal and vertical lines on this page, right? So vertical lines is when x equals some numbers, horizontal lines is when y equals some number. Now we need to talk about, well, what does horizontal lines look like in general form? So in general form, a horizontal line has this expression. So by plus c equals 0. So notice that there's no a because a equals 0 when you're dealing with a horizontal line. So recall that horizontal lines are a line that has the form of y equals some number. Okay. So recognize that y equals some number down here. And in general form, we usually deal with this. But understand that since a equals 0, this has been canceled out. So you're just left with by plus equals 0. Now you can solve for where your line is located by simply solving for y. So the equation of the line can be found by solving for y, and you'll always end up getting negative c over v. Do I recommend memorizing this? Absolutely not. Just recognize that you can solve for it. Vertical lines is the opposite, where b equals 0. Okay, so remember ax plus by plus c equals 0. Well, in this case, since b equals 0, this whole expression is gone. So you're left with ax plus c equals 0. And remember, a vertical line is where x just equals some number. And we can figure out where that's located by simply solving for x. So let's look at example 3 here, and we can sketch the graph of the following equations, and then we can describe the slope. So describing the slope is something we've learned in previous videos. So sketch the graph of the following equations. So here you can see there's no x value. So all we're going to do is solve for y. And we can already tell that this is going to be a horizontal line based on the information above. Okay, so let's solve for y. So 4y minus 3 equals 0. So I'm going to add 3. And I will end up getting 4y equals positive 3. And then I'll divide 4. So I get y equals 3 over 4, which also is 0.75. So on a graph, if we have 0.5 and then 1 right here, well, right here would be whereas y is 0.75. So any x value that occurs, your y value is always 0.75. So there is your line. And this is the line of y equals 0.75. Now, if we describe the slope here, well, this is a perfectly straight line. Remember what we talked about a perfectly straight line. A horizontal line has 0 slope. So there is our 2 of our answers now. That's what I wanted. Okay, so it has 0 slope. So now we're adding kind of everything we've learned into one equation. So hopefully that made sense. Let's maybe move on to this one here. So here we have 2x plus 8 equals 0. We'll recognize that we would already know this is just going to be a vertical line. Because b equals 0. Remember, when b equals 0, you're dealing with a vertical line. So now we're just going to find x. So 2x plus 8 equals 0. Subtract 8. 2x equals negative 8. And then divide 2. So x equals negative 8 over 2, which is simply negative 4. So we get an equation of x equals negative 4. So no matter what your y value is, x is always equivalent to negative 4. And that's why you have a vertical line. Because at negative 4 here, this is where your line is formed, perfectly straight down. And there is your line. X equals negative 4. Maybe I'll overlap this. So x at negative 4 is just a perfectly straight line. And remember what we talked about the slope of a vertical line. Remember, you can't define it. It's too steep. So slope is undefined. And finally, we'll try out C here. So if you have any questions with A or B, please come and ask. let's give C a shot. So first of all, recognize that A is equal to 0 again. So if A is equal to 0, well, then we're dealing with a horizontal line. Okay, and then we're just going to solve for y yet again. So we'll get 6y equals positive 2. Divide 6. And we will end up getting y equals, now recognize we get 2 over 6. And 2 over 6, both these numbers are divisible by 2. So we get 1 over 3. So y equals 1 over 3. And if you plug that in your calculator, roughly equals 0.33. So y equals 0.33. So if we were to graph this, and let's say we go up by increments of 1, 0.33 is roughly right here. So that's where our line is going to be formed. We will get our graph to look like a horizontal line that's simply where any number x is, y is always equal to 0.33. And again, let's maybe clean this up a little bit. There we go. Okay. And now remember, a horizontal line, their slope is 0. So m equals 0. And remember, we can think about it because if you have a perfectly flat surface, you would say it has 0 steepness. Okay? So hopefully that made sense. Just understand that general form is just a new way to represent the equation. You can represent a graph either in this form or this form, but recognize they graph the same equation. It's kind of like one person wearing different pants. So like here, this graph is representing itself in slope-intercept form, and down here it's representing itself as general form. Remember the rules of general form where you have all integers, and a has to be a positive. Okay, recognize if a is ever 0, so in this case, b has to be a positive integer. Okay, so that's just one thing to note. Let's maybe note that down. B must be positive integer. So if they ever asked you to represent a horizontal line in general form, that is something to note. If you have any questions, please come ask. I know things can get a little confusing, mainly because there's just so many different types of equations going on here. So if you need any help, feel free to send an email or come on in or see me in class. And otherwise, have a good day. Make sure you're practicing lots of problems.